Hey everyone, it's Eric with Crystal Cove Conservancy. I just wanted to give you a quick overview on how we can use Google Sheets to analyze our data to look for trends. If you've never used Google Sheets before, don't worry. It is very similar to Excel, a program that you may have used before. Google Sheets is a great tool to visualize and analyze data. It can help us when we're trying to answer our research questions that we have in place. So here on this sheet, we have one research question and a ton of data that can help us out. So let's take a look at this first research question and what it's about. So this first research question focuses on leaf litter decomposition rate. So more precisely, we're looking at which type of plant will decompose the quickest and which types will decompose the slowest. Water saver plants, water spender plants, or non-native plants. So we also have a lot of data that is paired with each research question that we've collected. So I always like to point out the bag type first. So the bag type is going to be the leaf litter bag type that we have placed in a location. So we have our water saver plants, our water spender plants, and our non-native plants. On the left hand side of that, you'll have a bag number that is just associated with each leaf litter bag type. And then each one of our leaf litter bags is going to be placed in a certain location or a certain plot. And those three types of plots are also a water saver plot, a non-native plot, or a water spender plot. And that's going to tell us what kind of plants were in that plot. We also have the initial mass, which is the mass that the leaf litter bag weighed when we initially put them out. And we have our final mass, which is the mass of the leaf litter bags when you helped us weigh that mass. Over on the right hand side of that, we will have the percent mass loss, which will tell us the mass loss of the leaf litter bags individually. This is going to be a very helpful area because it'll also help us determine the decomposition rate. With a percent mass loss, higher numbers on the percent mass loss mean that this lost a lot of mass or decomposed more. And other numbers that are much smaller will show that there wasn't as much decomposition happening. You may even see some negative numbers like the one here, which will show that mass may have been gained by these leaf litter bag types. And with those, that can be for multiple different reasons. We could have had dirt that got inside of the leaf litter bag, or it may have even had a plant grow inside of them, or it could be for many other reasons. We also have a few other research questions that we're going to look at. So the second research question looks at soil moisture. So where will soil moisture be the highest and where will it be the lowest in areas with water saver plants, water spender plants, or non-native plants. And then the data for that will have the plot number of where we collected that soil moisture, the plant type within that plot. So again, water saver plants, water spender plants, or non-native plants. And then the soil moisture percentage that we got for that plot. And then we also have our last research question, which is research question 3, effects on decomposition data. So here we're looking at where leaf litter will decompose the quickest and where it will decompose the slowest in areas that are restored or unrestored areas. So just like before, we'll have a plot type with our water savers and our non-native plots, also known as our restored plots and our unrestored plots. We have the bag numbers for each leaf litter type. Um, the bag type, which will tell you what type of leaf litter is within those bags. And just like before, our initial mass, our final mass, and then our percent mass loss for each individual bag. So let's first start by trying to visualize differences between the decomposition rate of our three leaf litter types. Each number here is the percent mass loss for one of those bags. And again, a higher number like 7.55 means that more of that mulch had decomposed, and a lower number like this 0.079 means that less of the mulch have decomposed. As you can see, each mulch type had some with more mass lost and some with less. We want to know overall, or in general, if one lost more mass than the other. So how can we find one number that represents all of these different types of data points? Take a moment to brainstorm some ideas.